Hello there, and welcome. I'm so glad you found your way here tonight. Maybe you're winding down from a long day, or maybe you're the kind of soul who prefers drifting into dreams with the quiet hum of the cosmos instead of counting sheep. However you arrived, you've landed somewhere soft, somewhere still. Tonight, there's nothing you need to do but listen. Let the weight of the day slide off your shoulders. Let your breathing slow and your thoughts loosen their grip. You're safe here. You're free to float. Because tonight, we're going somewhere distant, somewhere beautiful, a place that hangs in the velvet dark, more than 1 billion kilometers away from Earth, wrapped in light and shadow. We're heading toward the 6th planet from the Sun, Saturn, the jewel of the solar system, pale gold, slow spinning, and encircled by one of the most striking natural wonders in existence, its rings. You've probably seen them in photographs. That glowing disk of curves and curls, fragile looking, like they could vanish if you touched them. From a distance, they look like they were drawn on with a compass and a silver pen, so perfect they almost seem artificial. But the truth, as always in space, is deeper, stranger, lovelier than we imagine. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now, close your eyes, if you haven't already. Picture the stars above you, stretching out into the deep. Imagine rising from the earth, like smoke carried on wind. The continents fall away. The atmosphere thins. You pass the moon, then Mars, then the belt of scattered rock and metal between Mars and Jupiter. The sun shrinks behind you, turning from fire into gold. And ahead, there at island, Saturn. It doesn't glow like the Sunday. It doesn't burn or flare, but it shines, quietly, with a soft sheen, like pearl underwater. The planet itself is massive, over 750 times the size of Earth by volume. But there's a gentleness to it. It's made mostly of gas. No hard surface, no mountain peaks or oceans to crash into. Just layers of hydrogen and helium swirling endlessly around a small, dense core. Its winds are some of the fastest in the solar system, but from a distance, it doesn't seem violent. It seems calm, vast, dreamlike, and around it, the rings, they stretch wider than anything else of their kind. If you could unroll them, they'd span nearly 175 miles from end to end. That's about 3/4 of the distance between Earth and the Moon. And yet, they're barely 30 feet thick, as thin as a 2-story house, floating like lace in the dark. Up close, the illusion of a solid band breaks. The rings aren't one object. They're trillions of particles, pieces of ice and rock ranging from grains of dust to house-sized boulders, each one orbiting Saturn at incredible speed. They collide sometimes, softly, like snowflakes brushing against each other. And the result is a glowing ribbon of debris that looks still but never stops moving. It's like watching time itself shimmer. No one knows exactly how old the rings are. Some scientists believe they formed recently, geologically speaking, perhaps only 100 million years ago. Others believe they could be as old as Saturn itself, nearly 4.5 billion years. The truth may lie somewhere in between, but what's certain is that they won't last forever. The rings are slowly disappearing. Ice is falling into the planet. Dust is slipping away. In some far future, Saturn may circle the sun, unadorned, its once famous halo gone. But not tonight. Tonight, they're still here, still gleaming, still circling like the hands of a cosmic clock. There's a kind of silence to Saturn's rings, but it's not emptiness, it's presence. The kind of silence you feel in a snowy forest or under a sky full of stars. It's a hush that says everything is still happening, just quietly. As you drift closer, you begin to see the detail, the gaps and divisions, the way some sections curl tighter, denser, and brighter, while others fade into delicate arcs and ghostly strands. It's not just one ring, it's thousands, layered, interwoven, each shaped by gravity, by time, by the soft tug of Saturn's many moons. The planet has over 140 known moons, and many of them influence the rings like conductors guiding a symphony. Some carve gaps, some maintain edges. One, called Enceladus, sends out plumes of icy vapor from beneath its crust that help feed one of the outermost rings. It's as if the entire system is alive, breathing through the dance of its orbiting bodies. From Earth, we see Saturn's rings at different angles depending on where we are in our orbit. Sometimes they're wide open, fully fanned out. Other times, they seem to vanish, turning edge-on, just a razor-thin line against the blackness. They never stop. They only shift. Like the phases of the moon or the rhythm of tides, they remind us that beauty isn't fixed. It changes with your vantage point. So tonight, as your body sinks deeper into rest and your mind floats outward, remember that you're part of this. You are made of the same elements, carbon, water, dust, that swirl through those rings. You are not separate from the cosmos. You are a note in its song, a flicker of thought in the vastness of time. Let Saturn keep spinning. Let the rings keep whispering. Let everything slow down. We'll be here, watching quietly, drifting softly, listening always. From far away, Saturn's rings look like they were poured from silver, a perfect, unbroken circle carved into the sky. Through a telescope, they seem smooth, sculpted, almost solid, like you could skate across them or walk their curve as if it were the edge of a vast, luminous disk. But that illusion dissolves the closer you come. What appears serene and seamless is, in truth, something much stranger, something alive with motion. The rings are not solid at all. They are made of pieces, uncountable pieces, billions, perhaps trillions, of individual fragments orbiting Saturn in synchrony, some no larger than grains of dust, others the size of boulders or small houses. Each one follows its own path, circling the planet at speeds that defy intuition. They race through the vacuum of space at thousands of kilometers per hour, drawn by Saturn's gravity, kept in motion by the ancient balance between pull and momentum. From a distance, their countless orbits blur into one shining line, but they are not a single thing. They are many. Imagine a snowstorm, windless, silent, caught in a moment just before it lands. Every flake suspended, unmoving, lit from within. That is what Saturn's rings are like. A snowstorm frozen mid-drift, not by stillness, but by the perfect alignment of speed and gravity. They are not a structure of mass, but of movement, a choreography so vast and so precise that it creates the illusion of form. Each fragment within the rings obeys its own orbit, dictated by its distance from Saturn. The closer it is to the planet, the faster it must travel to avoid falling in. The farther out, the slower it drifts. This means that even though the rings appear to spin like a solid wheel, they do not move as one. They slide against each other. Outer particles fall behind while inner ones race ahead. There is friction. There are collisions, but they are often gentle. Glancing touches, brief nudges, tiny transfers of energy. It is this constant interaction that maintains the ring's shape and structure, smoothing chaos into order. Most of the particles are made of water ice, bright, reflective, and clean. That's why the rings shine so brilliantly in sunlight. The ice reflects light with a clarity that rock cannot match, casting the rings in soft white and silver hues. But mixed in with the ice are traces of darker material, dust, meteoroids, fragments of shattered moons. These impurities affect the color and brightness of different regions, painting subtle patterns across the ring's span. Some areas glow pale and pristine, others appear dusky, streaked with shadows. There is no surface to land on. If you could float into the rings, you would not stand upon them. You would drift through them, like moving through fog. Except the fog would be made of glittering ice, and each particle would be moving with speed and silence. You would see them pass all around you, above, below, beside, each a tiny moonlet on its own private journey around Saturn. You might hear the occasional soft ping of ice against your hull, or see a glimmer of sunlight reflect and vanish before you could focus. It would not feel like a wall or a barrier. It would feel like a river. The rings stretch wide, but their vertical depth is astonishingly thin. At their thickest, they are no taller than a 2-story building. At their thinnest, even less. For something so vast, this flatness seems impossible, but it's a product of time, of billions of years of collisions and gravitational nudges slowly ironing out their vertical motion. Any particle that rose too far above the rest would eventually be pulled back down, flattened into the plane by the combined force of everything else. Like a stream settling into its bed, the rings have found their lair. There are places where the density increases, where the ring becomes more crowded, more tightly packed. In those regions, the particles rub closer, brushing past each other, shifting slowly. Elsewhere, the material is sparse, almost ghostly. Gaps form, sometimes naturally, sometimes carved by the moons that orbit nearby. These empty spaces are not voids, but quieter places in the dance, where fewer dancers take the stage. This entire system, the illusion of stillness, the reality of movement, holds together only because of gravity. Saturn's immense pull guides every fragment, keeps each one in orbit, prevents the chaos from unraveling. But it is not just Saturn's gravity at work. The particles pull on each other too. Tiny tugs, collective weight. Over time, their mutual interactions form patterns, waves, wakes, edges, that ripple through the rings like music. These are not solid boundaries, but areas where harmony has taken shape. If you could watch the rings for hours or days, you would begin to notice their shifting, the way certain features twist and curl, how shadows stretch and shorten as Saturn turns. The system is in constant flux. It is not frozen. It only seems that way from afar. In truth, it is a masterpiece of balance, a structure made not of stone, but of rhythm. Even the brightest regions are composed mostly of empty space. The particles may be numerous, but they are not packed tightly. There is room between them, room enough to pass through. The glow you see is a trick of sunlight and ice and distance. The beauty lies not in the mass of the rings, but in the way that mass is distributed, aligned, and set in motion. The rings exist because of this equilibrium, not in spite of it. When you look at Saturn's rings, you are looking at a boundary that isn't real, a line drawn by movement, not matter, a border that changes constantly yet remains in place. What you see is a mirage made of physics and time, the result of millions of small things acting together, shaped into something that seems singular. It's a kind of illusion, one that nature plays not to trick us, but to remind us how much wonder can be born from the simplest of elements. Ice, rock, gravity, light. That's all it takes. And yet, somehow, it creates this, the illusion of a solid ring circling a golden world, gleaming quietly in the dark. From where we float now, far beyond the cloud-wrapped Earth, Saturn sits suspended in the dark, its golden glow wrapped in a luminous halo. The planet is massive, but what draws the eye? What steals the breath is the impossible spread of its rings. They encircle the world like a crown too wide for the head it rests upon, stretching outward in every direction with a grace so immense it's almost hard to accept as real. The rings of Saturn span over 175 miles from end to end. That's far enough to fit nearly 8 Earths side by side, edge to edge, within their reach. And yet, for all that breadth, they seem weightless, as if they could float forever. There's something otherworldly about their proportions. When we think of large things, we often imagine mass, thickness, bulk, substance. But Saturn's rings defy that. They're not heavy. They're wide, incredibly, extravagantly wide, and their scale becomes even more astonishing when you consider how close they sit to the planet. From Saturn's cloud tops, the rings begin just above the atmosphere and stretch outward into space like ripples from a stone dropped in still water. Only the ripples never fade. They keep circling. If you were to start at one edge and attempt to fly across, the journey would take hours. Imagine boarding a high-speed jetliner, cruising at 900 kilometers per hour. Even then, it would take well over 300 hours, nearly 2 weeks of continuous flight, to cross from one end of the rings to the other. And the entire time, you'd be skimming across a structure that, in many places, is barely taller than a house. A loop so massive it could encircle the Earth 7 times, yet delicate enough to vanish in silhouette if turned the right way. This vastness is part of the illusion. From Earth, the rings seem like a neat disk, tightly bound and compact, but distance deceives. They aren't snug against the planet. They're spread like a slow explosion, each band fanned outward into space. If Saturn were a spinning ballerina, the rings would be her skirt, flaring not from fabric, but from particles, ice, dust, and stone, each caught in perfect orbit. They have no beginning or end, no visible seam. You could follow the edge for hours, even days, and never find a break. They loop endlessly, turning with Saturn's gravity, forming a border that doesn't truly separate anything. There is no wall, no barrier, only motion, only balance. Now imagine this. Saturn itself is about 74 miles in diameter. The rings extend more than twice as far out from either side. If the planet were the hub of a wheel, the rings would be the spokes stretched to an almost absurd length. Or picture this. Take a child's toy hula hoop and place it on a table. Then imagine that same hoop scaled up until its inner circle could cradle an entire world. A planet sitting inside, spinning gently, while icy fragments dance around its middle in glittering lanes of orbit. It is difficult to convey just how large that island. We don't have many things on Earth that compare. If you tried to walk their length, moving at a brisk pace, it would take you over 3 years without stopping. And still, you'd be walking across something that isn't truly a surface, just a field of motion, a frozen river of ringlets, orbiting with such precision that they hold their form across tens of thousands of miles. From space, especially through the eyes of spacecraft like Cassini, the rings stretch across the camera's view like the edge of a vinyl record left spinning under starlight. But they are not flat, not perfectly. Tiny warps ripple through the ring plane, bends and oscillations caused by Saturn's moons, by gravity's pull, by the ever-present sway of mass and momentum. But overall, their symmetry remains astonishing. For something made of fragments, they hold their shape like sculpture. Astronomers divide the rings into lettered bands, A, B, C, D, E, F, and G. But these names don't describe a clear order. They are echoes of discovery, of the order in which they were first observed. The true structure is more layered, more intricate. The A and B rings are broad and bright, forming the heart of the system. The C ring is dimmer, translucent. The D ring lies closest to the planet, whisper-thin and faint. Beyond the visible lies the E-ring, diffuse and misty, fed by the icy plumes of Enceladus. The F-ring winds and twists, a thread tangled by moons. Each ring tells its own story, and each stretches outward in a chorus of quiet motion. It's hard to believe something so expansive can remain so steady, that the immense reach of the rings doesn't unravel, but they do hold. For now, their breadth is part of what makes them vulnerable. As they extend farther into space, they interact with more micrometeoroids, radiation, gravity. They are exposed, yet somehow they endure. To stand near them, if such a thing were possible, would be like watching the edge of time. You would see layer upon layer of icy debris, each orbiting with quiet determination. You would witness shadows cast across thousands of kilometers as sunlight angles in. You'd see flares of brightness, where particles cluster and soften where they thin. It would not be empty. It would be alive with detail, the kind of detail you can only see when you let yourself drift long enough to stop searching for edges. Saturn's rings are a paradox. They are massive, but delicate, bright, yet composed mostly of empty space. They reach farther than almost anything else in the solar system that isn't alive, but they remain mostly hidden in plain sight. A gossamer halo stretched wider than most moons, glimmering in silence, circling a world that has no ground. And in all that width, that glorious 175 zero-mile sweep, what you see is not just scale, you see balance. A universe capable of drawing perfect lines not with rulers, but with gravity, motion, and time. From a distance, Saturn's rings look like something strong. They hold shape, they shine, they orbit with elegance and steadiness, so symmetrical they seem permanent. And with a width of 175 zero miles, it's easy to assume they must be massive in every dimension. But they are not. Not even close. For all their sprawling breadth, the rings of Saturn are only about 30 feet thick. 30 feet, about the height of a modest building, a 2- or 3-story home. That's all. If you could pull one ring from the system and place it in a field on Earth, you could climb a staircase and look right over the top. And yet, from millions of kilometers away, that paper-thin layer of ice appears like a fortress of light. That's the wonder of it, the contradiction. That something so immense can also be delicate. That something stretching across so much space can exist in a sliver of depth. It's hard to wrap the mind around it. If you built a scale model where Saturn was the size of a basketball, its rings would still be thinner than a human hair. That's how narrow they are relative to their span. It would be like stretching a sheet of silk around a globe and having it remain suspended in place, perfectly flat, perfectly stable, moving in rhythm but never breaking, fragile not because of weakness, but because of balance. That thinness isn't an accident. It's the product of countless years, billions, possibly, of small adjustments. The particles within the rings have been colliding for ages. Tiny bumps, gentle crashes. Over time, these encounters have smoothed out their vertical motion. Anything that tried to rise above the ring plane got nudged back down. Anything that dipped too far below was pulled upward again. Gravity, like an invisible hand, pressed them all into a single, luminous sheet, and still they orbit. Even now, they race around Saturn at incredible speeds. The particles closest to the planet make the trip in about 6 hours. Farther out, it takes longer. But all of them, every piece of ice, every grain of dust, is bound to this razor-thin path, trapped not by force, but by equilibrium, the kind of quiet agreement that only gravity can create. If you could fly alongside the rings and tilt your view to see them edge on, they might vanish. From the right angle, their vertical profile is so small that they become invisible. Just a thread of brightness, a shimmer, as if the planet is wearing a belt of light so fine it barely casts a shadow. That's part of why they seem to disappear from Earth every 14 or 15 years. As Saturn orbits the Sun and our perspective changes, the rings tilt until they're edge-on to our view, and for a little while, they seem to slip out of existence. But they don't. They're just hiding in their own thinness. This thinness also means the rings are fragile, not easily broken, but susceptible to change. Micrometeoroids strike the particles often, chipping away at the ice, adding dust, darkening the material. The sun's light slowly alters the surface chemistry of the ice, baking it, changing its reflectivity. Over time, these processes eat away at the rings. And though they appear serene, they're always evolving, always adjusting. That 30 feet is a dynamic zone, a thin shell of quiet chaos. And yet, in all this motion, they stay so flat, so consistent. It's as if the entire ring system knows its limits and respects them. There's no towering stack of debris, no dramatic arcs rising miles above the plane. Everything flows horizontally, like a perfectly calm sea stretched across the sky. There is peace in that flatness, a stillness that speaks of age and patience. It's tempting to compare the rings to a vinyl record or a disc of glass. But even those feel too stiff. Saturn's rings are not hard. They're soft, not in texture, but in presence. Imagine a veil, thin, translucent, laid across a planet 100 times larger than Earth. A veil made not of fabric, but of ice and dust and sunlight. It doesn't weigh the planet down. It doesn't cling. It floats. And in its floating, it reveals just how much elegance can be made from chaos. The thickness of the rings varies slightly depending on the region. Some places are more crowded with particles, others more sparse. But in most areas, that 30 feet is all they need. Just 30 feet to contain the brilliance of millions of tiny worlds. Some particles are as small as powdered sugar. Others are closer in size to trucks or buses. But none rise above the invisible ceiling of the ring plane. They don't climb. They just orbit, endlessly, in a layer as flat as a dream. And so we watch from afar, seeing this massive band of light stretched around a golden world, not realizing at first that we're witnessing something almost impossibly thin. We think of space as grand, as vast, as filled with scale too large to grasp. And yet, the beauty of Saturn's rings lies not in their size alone, but in their restraint. They show us that wonder doesn't always require mass. Sometimes it just requires symmetry, motion, and the soft hand of gravity pressing everything gently into place. In the end, that's what the rings are. A miracle of proportions. A halo made of countless parts, arranged not in chaos, but in a kind of whispered order. Wide enough to stretch across a planet's sky, thin enough to vanish in profile, fragile but enduring, light but permanent. And in that delicate balance, they remind us that sometimes the most breathtaking structures in the universe are not the ones built tall, but the ones stretched impossibly thin, held together by the quiet promise of motion and time. When sunlight touches Saturn's rings, it sets off a shimmer that's unlike anything else in the solar system. It's not just a reflection. It's a kind of glow, as if the rings have been dusted with light itself. They gleam with a soft white brilliance, like freshly fallen snow on a moonless night. And at the heart of that glow lies something simple, something surprisingly familiar. The rings of Saturn are made almost entirely of water ice, roughly 95%. That's the estimate. Water, frozen solid, stretched out across hundreds of thousands of miles, not in the form of glaciers or smooth sheets, but as individual particles, ice chunks and shards, some the size of sugar crystals, others like boulders, drifting in a slow, steady current around the gas giant. They move in silence, orbiting with purpose, and when the light from the sun hits them just right, they shine like a halo made of glass. That brightness is what made the rings so captivating to early astronomers. Through even the simplest telescopes, they appeared luminous, almost self-lit. But it's not fire or magic, it's ice, reflecting nearly all of the sunlight that reaches it. Water ice, especially when it's clean and undisturbed, is an extraordinary reflector. It catches light and sends it back, not in harsh flashes, but in a quiet radiance that seems to hover just above the visible. That's what we see from Earth, a ring system that catches the sun and holds it gently. The remaining 5% is dust, rock, and possibly carbon-based compounds, darker materials, the shadows in the otherwise pristine landscape. These tiny fragments don't shine the way the ice does. They absorb more light, lending the rings a faint variegation. Subtle differences in tone and color, barely perceptible from afar but unmistakable up close. These impurities gather more in some regions than others, creating patterns and stripes that ripple across the ring plane like brushstrokes left by time. But they're passengers, not drivers. The ice is what gives the rings their character. The ice is what turns orbit into art. Where this ice came from is still a mystery. Theories swirl like the particles themselves. Some believe the rings were formed from the remnants of a shattered moon, an ancient satellite of Saturn that strayed too close and was torn apart by the planet's gravity. Others imagine a comet, pulled inward and broken down piece by piece, its icy core dispersed and caught in orbit. Still others suggest the rings are as old as Saturn itself, leftover material from the formation of the planet, never gathered into a moon, simply hanging on in luminous defiance of gravity's usual rules. Each theory carries its own weight, but none are certain. The age of the rings is debated. Some argue they are young, just a few 100 million years old, a blink in cosmic time. Others think they could be primordial, older than the dinosaurs, older than Earth as we know it. If they are young, it would suggest that the ice is relatively clean, unweathered by billions of years of micrometeoroid strikes and solar radiation. If they are ancient, then the brightness we see today would mean they are somehow constantly renewed, maintained through collisions that expose fresh ice, kept alive by a cycle of destruction and rebirth. What we do know is that this ice is extraordinarily pure. It hasn't been polluted by the thick atmosphere of a planet, or by volcanic processes or tectonic churning. It's just ice, cold, clean, and ageless, the kind that hasn't melted since the moment it formed. And floating in the void around Saturn, it remains untouched by fire or erosion. There is no wind here, no rain, only the occasional tap of another fragment, a slow-motion collision in a system ruled by patience. Sometimes, you can see the difference in sunlight. When the sun sits behind Saturn and the light grazes the rings at a low angle, their true texture is revealed. Shadows appear. The three-dimensionality of the system becomes apparent. Tiny vertical ripples, clumps, and wakes rise and fall. And through it all, the ice glistens, not harshly, not like glass, but softly, like the glint of frost under morning light, or the sheen of moonlight on still water. This is why, from Earth, the rings seem to glow. It's not because they are powered from within, but because they reflect what is already there. The sun's rays arrive after traveling nearly 1 billion miles, and when they strike the rings, they don't just bounce. They are echoed back, dispersed across miles and miles of frozen surface. The result is something ghostly and serene, a ring system that lights up not by force, but by grace. Even in shadow, the ice holds its form. When the rings pass into Saturn's night side and the sun is blocked, they do not vanish. They remain suspended, a scaffold of ice waiting for light to return, and when it does, the shimmer begins again, as if nothing ever stopped. This quiet resilience is what gives them their presence, the ability to seem eternal, even when they are made of fragments. So much of space is dark, so many things absorb the light, hide from it, drift in shadow. But Saturn's rings stand apart. They catch the light and wear it. They reflect it back across the cosmos. Not with brilliance, but with elegance. Because ice, in its most untouched form, knows how to hold light without needing to keep it. And that's the secret. That's why the rings shine. Not because they are solid or heavy or even permanent, but because they are made of something simple: water, frozen in orbit, ice, circling a gas giant. And in that simplicity, they become luminous. They become beautiful, not in spite of what they're made of, but because of it. When you look at Saturn's rings from afar, they appear continuous, like a single gleaming loop cast around the waist of a gas giant. But up close, that illusion dissolves into detail. The rings separate, pull apart, reveal their architecture. They are not one band, but many. Scientists, searching for clarity, have given them names: A, B, C, D, E, F, and G. Simple letters for something impossibly complex. The names were never meant to be poetic. They were assigned in the order the rings were discovered, not in the order they lie. But still, somehow, the simplicity of the lettering fits. Clean, quiet, unintrusive, just like the rings themselves. The A ring is broad and bright. It lies on the outer side of the system, separated from the B ring by the Cassini division. A thin, dark gap that isn't truly empty, but sparse enough to seem like a wound cut into the ring plane. The B ring, by contrast, is the most massive and reflective, thick with ice and structure. The C ring lies inward, fainter and more diffuse, barely visible against the planet's golden glow. Closer still is the D ring, so wispy it's often lost in the background. And farther out, beyond the main trio, you find the G, E, and F rings. Thinner, more delicate, often braided or warped, held together by the gentle shepherding of Saturn's moons. These rings aren't stacked like layers on a cake. They are more like strands in a spider's web, each in its own place, each held in balance. Some have sharp boundaries. Others blend into the dark, like fog drifting into the night. The F ring, in particular, is a marvel of instability. It twists and kinks under the influence of nearby moons, sometimes forming bright clumps, sometimes pulling itself thin. It is not a ring that stays still. It dances, it coils, it renews itself in near real time. For early astronomers, seeing the rings at all was enough of a miracle. Galileo was the first to observe them, back in 1610, though his telescope was too primitive to resolve their shape. To him, Saturn looked like a triple-bodied star, one large orb flanked by two smaller ones. He described the planet as having ears. It wasn't until Christian Huygens, several decades later, that the truth was revealed. Saturn was surrounded by a thin, flat ring. Later still, Giovanni Cassini identified the major gaps, and the rings began to earn their names. The lettering system we use today began in the 19th century, as astronomers with better optics cataloged more detail. The B ring was the brightest, so it was noticed early. The A ring, next out, followed. The dimmer C ring was found after. The others came later, as technology advanced and space missions ventured closer. The naming never tried to be poetic or beautiful. It was practical, scientific. But over time, the letters took on meaning. They became symbols not just of order, but of wonder. A code we could use to talk about something almost impossible to imagine. But while the names help us map the rings, they don't tell us how long they've been there. That part is still a question without a firm answer. For years, scientists believed the rings might be nearly as old as Saturn itself. Over 4 billion years, born from the same primordial cloud that formed the planets. That would make them ancient beyond comprehension, survivors from a time before Earth had oceans. But recent data complicates that story. Observations from the Cassini spacecraft suggests the rings might be far younger. Some estimates place their formation just 100 million years ago, a blink, cosmically speaking. If true, the dinosaurs on Earth would have lived under a night sky where Saturn was still ringless. And only after they vanished would the rings have arrived, perhaps from a moon that wandered too close and was shattered by Saturn's gravity. Its icy bones spread out into orbit. One of the reasons scientists suspect youth is brightness. The rings are incredibly reflective, which suggests they haven't been exposed to darkening dust and radiation for long. Over billions of years, the rings should have darkened, grown dull, but they haven't. They remain brilliant, fresh, almost new. That suggests either they formed recently or something is constantly renewing them. Some mechanism we don't yet understand, cleaning the ice, exposing fresh surfaces, keeping the glow alive. But it's also possible the rings are older and simply more active than we realized. Perhaps the collisions between particles keep the system stirred up, always shifting, always erasing the wear of time. Maybe the rings have a way of repairing themselves, of shedding the dark skin of age and revealing a brighter core. And so, the question of age remains open. Are we witnessing a fleeting phenomenon, a temporary miracle that will one day fade? Or are the rings a permanent fixture, a patient artifact from the dawn of the solar system? We don't know. And that uncertainty adds to their allure. Because if the rings are young, we are lucky, living in the narrow slice of time when they exist. But if they are old, they've been watching us since before we were anything. And either way, they remind us of how little we truly know. Each ring, A, B, C, D, E, F, and G, holds its own secrets. Each carries a different density, a different width, a different story written in ice and orbit. They are not static. They shift, respond, ripple with the movements of nearby moons. They have names, but those names don't capture the full truth. They are not just letters. They are layers of time, stacked and moving. And perhaps that's the deeper beauty of the rings. Not just that they circle Saturn, but that they circle time itself. They hold memories older than memory. And as we study them, as we give them names and assign them ages, we are trying to translate a language that was written long before we arrived. A language of ice, a language of light. When you first glimpse Saturn's rings, even through a small telescope, two features call out immediately. Broad arcs of brilliance encircling the planet, and a narrow dark line dividing them like a scar cut into perfection. These are the A and B rings, the brightest and most substantial of all. They do not simply reflect light. They scatter it, throw it softly into space in such a way that it lingers on the eye, like the glow of frost under morning sunlight. The B ring, closest to Saturn among the two, is the densest and brightest of them all. But the A ring, slightly farther out, is no less captivating. Between them lies the Cassini division, a darkened gap named not for absence, but for discovery. The B ring carries more mass than all the other rings combined. It is thick with icy particles, densely packed, orbiting in tight formation like a crowd moving through an invisible corridor. Its reflectivity is a function of both its content and its nature. Pure water ice, stirred and polished by countless collisions. That brightness isn't flat or uniform. It changes subtly as you move across its width, patchworks of shadow and clarity forming where denser clumps gather and loosen again. When sunlight hits it, the B ring responds not with glare, but with depth. It gleams in layers, like moonlight woven through snowfall. But the A ring holds its own mystery. Though it contains less mass, it is nearly as bright and stretches wider than its companion. And it cradles the Cassini division, a rift first observed in the 17th century that became a symbol of space itself, a reminder that not everything beautiful is smooth or whole. The division is not truly empty. Particles still orbit there, but they are sparse enough to let shadow dominate. Seen from Earth, The Cassini division adds dimension to the rings, revealing that they are not a single surface, but a layered system of complexity and contrast. Together, the A and B rings form the core of what we see when we picture Saturn, two luminous bands wrapping the planet in quiet grandeur. Their brightness is not just a trick of composition, but a reflection of orientation. When the rings are tilted toward Earth, their full surface shines. When they tilt away, the glow fades slightly, not because they change, but because our view does. They are a mirror held to the sun, and their gleam depends on where we stand. It's tempting to think that the brightness of a ring must relate to its age, that the most radiant must also be the youngest, the cleanest, the most recently formed. But space does not move according to our assumptions. Brightness, in this case, tells a different story. The B ring may be ancient or recent. We do not yet know. Its shine comes not from youth, but from content, from the sheer abundance of icy material and the way that ice reflects the sunday. Over time, exposure to radiation, dust, and micrometeoroids should darken the surface of icy particles, coating them in grime, softening their shine. But collisions between ring particles can strip away that aged surface, revealing fresh ice beneath. In this way, the rings might renew themselves, not by being new, but by acting young. This opens a door to possibility. The rings may be old, but constantly refreshed by their own internal dynamics. Each time two particles collide, they fracture slightly, breaking off bits of old surface and revealing the cleaner crystal beneath. This process plays out millions of times across the ring system, a kind of slow-motion exfoliation happening on a planetary scale. So, when we see brightness, we are not necessarily seeing newness. We are seeing activity. We are seeing motion. We are seeing time, always in motion, never allowed to rest. In the B ring's densest regions, sunlight can't even fully penetrate. The outermost layers catch the light, but beneath them, there may be shadows. Zones where particles orbit in partial darkness, hidden by the very brightness above. And that contrast is what makes the B ring so beguiling. It is not a wall of light. It is a lattice, a woven field, rich with depth and change. The A ring, by comparison, feels more open. Its structure is still dense, but less so than the B ring. Light moves through it differently, casting longer shadows, creating broader bands of shine and silence. And nestled within, the Cassini division acts like a breath between phrases, a pause that gives the whole composition rhythm. Without that gap, the ring system would seem less alive. With it, Saturn gains a kind of punctuation, a natural division that reminds us even beauty needs space. Even the gaps within these rings tell stories. The Encke gap and the Keeler gap, narrow divisions inside the A ring, are maintained by tiny moons, their gravity shepherding particles keeping paths open. These little moons, often no larger than cities, help define the architecture of the system. They don't shine the way the rings do, but they guide the shine. They give form to the gleam. And so, when we talk about brightness, we are not just talking about light. We are talking about structure, density, chemistry, and motion. We are talking about ancient ice stirred by invisible forces. We are talking about sunlight rebounding across 1 billion miles to reach our eyes and carrying with it a story written in glints and shadows. The A and B rings are not brighter because they are simpler. They are brighter because they are more dynamic. Their surfaces are scrubbed by gravity, burnished by collisions, carved by the unseen hands of passing moons. And in that dance, they remain reflective. Not in the way a mirror is, but in the way a river island, always flowing, always flickering, always telling a story if you know how to listen. And we do listen. We tune our instruments. We point our spacecraft. We chart the difference between the shadow of the Cassini division and the glare of the B ring. And what we learn is that light in space is a language all its own. not loud but persistent, not explosive but patient. And in the space between Saturn's brightest rings, we find silence filled with meaning, a silence made not of absence, but of ice and light, moving endlessly, beautifully, through time. From a distance, the Cassini division looks like a void, a slender, darkened seam slicing through Saturn's luminous rings, a pause in the light, a silence in the music. It appears as though someone took a fine blade to the ring plane and gently cut a line, neat and unbroken, between the A and B rings. For centuries, it was spoken of as a gap, a space between spaces, a celestial no man's land. But like so many things in the cosmos, the truth is more subtle than the image we first see. The Cassini division isn't empty. It only seems that way because our eyes are drawn to light, and the division reflects far less of it. But within that soft darkness lies motion. There are still particles there, dust, ice, fragments of matter orbiting Saturn at different speeds, tugged and teased by invisible forces. The division spans about 920 miles across, which, on Earth, would stretch from New York City to Los Angeles and halfway back again. And through every inch of it, countless ringlets thread their quiet orbits, faint and diffuse. Gravitational interactions are the architects of this illusion. Saturn's moon Mimas, orbiting farther out, exerts a powerful influence on particles within the Cassini division. The ring particles that try to orbit within this space find themselves in a precarious dance with Mimas's gravity. At one particular distance, a location known as a resonance, Mimas completes one orbit for every 2 orbits the particles make. That rhythmic gravitational tug creates instability, gently but relentlessly pulling particles out of that region over time. Over millions of years, this process has carved away much of the material, leaving behind a region that's not empty, but quiet, dimmed, thinned, and sparsely populated. But not abandoned. There are still ringlets here, narrow, barely visible strands of ice and dust that hold their orbits in defiance of the resonance. Some are stable, their paths carefully threaded through the gravitational chaos. Others are temporary, held briefly before being scattered outward or drawn inward. And between them, ghost particles drift, too small to reflect much light, but present all the same. These are the motes of cosmic dust, born of collisions and micrometeoroid impacts, leftovers of long-forgotten structures. They do not announce themselves, but when the sun hits the rings at a shallow angle, their shadows betray them. Brief streaks on Saturn's atmosphere, fleeting signals from objects we cannot see directly. The darkness of the Cassini division is a trick of scale and contrast. It stands between 2 of the brightest rings, A and B, and in comparison, it seems like absence. But if it were viewed on its own, without the gleaming boundaries beside it, it would appear as a fine, delicate ring structure in its own right. Not luminous, but present. Not solid, but stirring with quiet life. It is not an absence of material, it is an absence of brightness. Even within the division, structure exists. There are density waves, ripples that travel through the particles, caused by gravitational nudges from Saturn's other moons. These waves are patterns, like grooves on a vinyl record, spiraling slowly, carrying with them echoes of the forces that shape them. Some of these waves mark the edges of ringlets, while others pass through, creating zones of compression and release. Each wave is a whisper of motion, a trace of gravitational memory written in the language of orbiting ice. And this is what makes the Cassini division more than just a gap. It's a conversation between mass and motion. The visible rings may be the poetry of Saturn, but the divisions are the punctuation, the spaces that allow the rhythm to breathe. Without them, the rings would be overwhelming, a blur of endless brightness. But with them, there is contrast, there is cadence, there is form. The spacecraft Cassini, which orbited Saturn for over a decade, gave us our most intimate look into this region. As it passed above and through the rings, it captured high-resolution images that revealed details we never imagined. Fine threads of material arcing through the division, wave-like distortions rippling across the ring plane, tiny embedded moonlets casting shadows as long as cities. And the confirmation that the Cassini division is not truly a void, but a landscape of restraint. Even the name, division, carries a quiet irony. It implies separation, yet the Cassini division connects as much as it divides. It links the A and B rings, not just spatially, but through interaction. The B ring's outer edge and the A ring's inner edge both respond to resonances from moons beyond. The division itself becomes a field of gravitational balance, a negotiated space where particles pass, pause, and sometimes vanish. And perhaps that's what draws us to it, the way it seems to hold the tension between presence and absence. It's a place where forces contend, where light dims but never goes out, where space is shaped not by what is there, but by what is kept away. It's a reminder that not all beauty is found in what we can see clearly. Sometimes, the most delicate structures are those that seem to disappear unless we look very closely. The Cassini division isn't a boundary, not in the way of Fence Island. It's more like the silence between notes in a song, the breath between thoughts. It's the space that allows the rings to have shape, to have contrast, to be more than just a seamless band of light. It is the whisper between Saturn's louder declarations. In that whisper, there are particles still moving, ice still reflecting, shadows still cast, a symphony still playing, even if we can't always hear it. And so, the next time you see a picture of Saturn and notice that thin, dark line, remember what lies within it. Remember that the dark is not always empty, that space is never truly silent, that even the quietest parts of the cosmos have stories to tell. If the A and B rings are Saturn's grand, sweeping symphony, broad and luminous and orderly, then the F ring is its strange, unpredictable jazz. It coils just beyond the A ring, narrow and delicate, but alive with tension. A slender strand of particles, barely wider than the width of a few city blocks, and yet capable of movements that seem almost too expressive for something made of dust and ice. Unlike the stately elegance of its brighter cousins, the F ring does not hold still. It writhes, it loops, it knots, and untangles itself, sometimes in the span of a single orbit. The F ring's beauty is not in its consistency, but in its refusal to be confined. It is chaos made graceful, a narrow thread of activity traced by invisible hands. And those hands belong, in part, to two small moons, Prometheus and Pandora. They are called shepherd moons, and the name is more than poetic. Like sheepdogs herding a cosmic flock, these moons orbit on either side of the F ring, their gravity pulling gently at its edges, shaping it, disturbing it, maintaining it, and disrupting it, all at once. Prometheus travels on the inside edge of the F ring, and with every pass, it dips into the ring's material, tugging small streamers of particles behind it like wisps of hair caught in a breeze. These encounters don't go unnoticed. They leave scars, kinks, channels, ripples that propagate down the ring, like echoes of a touch. Pandora, trailing just outside the ring, acts in her own way, keeping the outer edge in check, but not with strict control. Her influence is softer, but not passive. She too shapes the boundary, contributing to the instability that defines this strange, shifting place. Between them, the two moons create a kind of orbital tension, a gravitational tug-of-war in which the ring itself is the rope. But unlike most ropes, this one is not stretched taut. It flexes, it flutters, it grows turbulent, and then, astonishingly, it smooths out, only to ripple again. The F ring does not settle. It does not seek calm. It seems to thrive in a state of almost constant unrest. Sometimes, bright clumps of material appear in the ring, unexpected, concentrated gatherings of ice and dust that shine briefly, then fade. Scientists believe these may be the aftermath of collisions or temporary aggregations, like eddies forming in a river. There may even be small moonlets, tiny, irregular chunks of matter, too small to be seen directly, lurking within the F-ring, occasionally disturbing the flow, briefly gaining mass, and then dispersing again. Nothing here holds its form for long. The F-ring's core is surrounded by a halo of faint, dusty material that stretches far beyond the narrow visible band. It's as if the ring carries with it a memory of all the shapes it has ever tried to be, a blurred record of its own instability. This haze of fine particles catches light in strange ways, sometimes casting shadows, sometimes glowing faintly, like breath on a cold window. It is the signature of activity, a kind of atmospheric residue left behind by all the stirring and shifting that takes place inside. What makes the F-ring even more remarkable is how it shows time in motion. Images taken just hours apart can look radically different. A sharp bend smooths out. A streamer appears where there was none. A knot unwinds. There is a kind of restlessness here that defies the frozen silence we often associate with space. And yet, none of it makes a sound. No crash, no roar. Just the soft ballet of countless particles adjusting their course in response to gravity's gentle prodding. It is difficult to imagine anything so fragile behaving with such drama. The F-ring, at its thickest, is made up of ice particles, no larger than pebbles, most much smaller. They orbit Saturn at thousands of miles per hour, but in such thin formation that if you were to fly through the ring, you might not even notice the collisions. And yet, over time, these minuscule particles shape patterns of immense scale. Spirals, braids, arcs. They compose a constantly evolving calligraphy, invisible to the naked eye but rendered visible through the patient gaze of our spacecraft. The Cassini mission, during its long and daring tour of Saturn, brought us closer to the F-ring than ever before. It revealed the ring's unpredictable heart, how it could appear braided in one moment, smooth the next, and then fractured after that. It taught us that the ring was not a passive structure, but a dynamic system, a place where the laws of gravity play out like choreography, each particle responding to the music of the moons around it. Prometheus and Pandora, bound in their shepherding roles, don't control the F-ring so much as they challenge it. They give it edges and then disturb those edges. They coax it into structure and then scatter that structure like petals in the wind. And through it all, the F-ring keeps orbiting, never the same twice, always a little bit off balance. There is a certain comfort in the order of the main rings, the clean symmetry of the A and B rings, the familiar glow, the elegant spacing. But the F-ring reminds us that not all beauty is neat. Some of it is raw, kinetic, and unwilling to be pinned down. It is a place of tension and impermanence, a visible sign of how gravity shapes not just form, but behavior. And perhaps, in its strange, flickering way, the F-ring speaks to something universal, that the most alive systems are the ones that resist stillness. That stability is not always the same as calm. That chaos, when held within a boundary, can be its own kind of order. Here, at the edge of Saturn's rings, we find a place where even the smallest pieces of matter create grand movements, where moons barely larger than mountains stir a strand of ice into knots, and where the line between control and freedom is never entirely clear. The F-ring is not consistent. It is not polished, but it is alive and always in motion. And in the quiet sweep of the planet's shadow, it twists and turns, forever rewriting its shape, like a ribbon caught in the wind of an unseen world. The D-ring is the innermost of Saturn's rings, and in many ways, the quietest. It hugs closest to the planet's cloud tops, a thin, almost transparent veil of material stretched just above the atmosphere, too faint to be seen with most telescopes, too delicate to cast much shadow. If the brighter rings are declarations, broad, bright, undeniable, then the D ring is a whisper, a lingering breath drawn in close. It doesn't announce itself. It waits to be discovered. Its particles orbit Saturn at tremendous speeds, caught in a region where gravity begins to blur the line between what is a ring and what is atmosphere. The proximity is so close that some of the particles may actually brush against the outer fringes of Saturn's exosphere. It's a place of tension, where orbital stability teeters on the edge of surrender. The D ring is not merely close, it is intimate. Unlike the broader, denser rings farther out, the D ring is ephemeral, nearly invisible from Earth, and barely captured even by the Cassini spacecraft. Its structure is subtle, a gauze of fine dust and small icy grains stretched over tens of thousands of miles, yet sparse enough that light passes through almost unimpeded. It does not reflect with the same brilliance as the A or B rings. Instead, it shimmers faintly, like moonlight on thin mist. It is there, but only just, and it may be disappearing. Data from Cassini suggests that the D ring is losing material, possibly being eroded by Saturn's magnetic field or gradually pulled downward by the planet's gravity. Some of its particles may spiral inward, descending into Saturn's atmosphere like quiet snow. Others may be swept away by electromagnetic forces, driven outward or dispersed into space. Its brightness has been observed to fluctuate over the decades, hinting at an unstable existence, a ring in retreat. This shrinking, if confirmed, gives the D ring a sense of fragility that even the other rings, delicate as they are, don't quite share. All of Saturn's rings are subject to slow change, collisions, erosion, the relentless sculpting of time. But the D ring feels especially fleeting, a thing not just shaped by time, but perhaps running out of it. The mystery of its origin adds to this feeling. No one is quite sure how the D ring formed. It may be a remnant of older, broader structures that once stretched closer to Saturn and have since been eroded away. Or it could be a temporary phenomenon, created by material falling inward from the outer rings or ejected from Saturn's atmosphere during storms. In some ways, the D ring feels less like a sibling to the others and more like a ghost, an echo of some former state, or a preview of what other rings may one day become. And yet, it has its own complexity. Within the D ring are multiple faint strands, labeled D73, D68, and others by scientists. These aren't names that resonate like Cassini division or Encke gap, but they represent structure. Not all of the D ring is smooth haze. There are ripples, arcs, and fine waves etched into the dust, patterns that suggest activity even in this quiet place. One of these regions, D68, is especially intriguing. Cassini passed near it in its final orbits and observed narrow, bright clumps that may have been created by collisions or interactions with moonlets too small to detect. It was like seeing footprints in dew, evidence of presence, even if the walker is nowhere to be seen. And because the D ring lies so close to Saturn, it is also a boundary, not a hard line, but a zone where the planet begins to take over, where ring becomes sky. The radiation environment here is intense, saturated with charged particles trapped in Saturn's magnetic field. Any dust that lingers too long will be altered, charged, pushed, pulled, and eventually erased. This is a place of transition, where permanence is not expected, and survival is brief. It is strange to think that something spanning tens of thousands of miles could feel small, but in the context of Saturn's immense gravity and the grandeur of its other rings, the D ring truly does. It is almost personal, as though Saturn, massive and impassive as it is, wears a thin scarf just beneath its chin, a final touch of softness before the vastness above begins. The D-ring also reminds us of just how much we still don't know about Saturn's ring system. We often talk about the visible, the dramatic, the massive structures that command attention. But here, in this faint halo of dust, is a lesson in nuance. The ring exists at the edge of detectability, challenging our instruments, testing our patience. And yet it is part of the story, a chapter that might be fading, but deserves to be read while it remains. Its closeness to Saturn means it doesn't have much time. Some of its particles are already falling. Cassini's final plunge through the gap between the planet and the innermost rings confirmed what many suspected. The D-ring is not static. Material is on the move. Gravity, magnetic forces, and atmospheric drag are all conspiring to draw the ring down. If the ring could speak, it might tell us it was never meant to stay, that it was always a passing moment. Still, in its quiet way, it reflects something deeper about space. Not all stories are told with brilliance. Some arrive softly, disappear quickly, and yet leave behind traces that linger. A ripple in brightness, a scattering of particles, a memory caught in data. The D-ring is fading, perhaps, but for now, it is still there, still circling, still whispering. The E-ring is a pale ghost wrapped around Saturn, so diffuse that it often goes unnoticed, a shimmer against the black, too soft for most eyes. But hidden in that whisper is one of the most beautiful, ongoing miracles in our solar system. A ring made not by collision or debris, but by a moon that breathes. That moon is Enceladus. Small, icy, and deceptively bright, Enceladus orbits deep within the bounds of the E-ring, and though it looks still and silent from afar, its surface hides a secret. Beneath the frozen crust is an ocean, and from that hidden ocean, through great fractures near its south pole, tiger stripes, scientists call them, plumes of water vapor and ice erupt into space in long, glittering arcs. These geysers are not short-lived bursts. They are continuous fountains, streaming material out into Saturn's orbit in a ballet of pressure and release. And the ice grains that escape Enceladus don't just drift away. They join something larger. They become the E-ring, that one moon, with a diameter barely 500 kilometers across, feeds an entire ring system. It is a strange, beautiful act of creation. Most rings in the solar system are remnants, leftovers from collisions or shattered moons, built from what was broken. But the E-ring is alive, or at least, it is made by something that behaves as though it island. It is not a relic of ancient violence, but an ongoing gift, remade every day as Enceladus continues to spray its icy breath into the void. The ring itself stretches farther than any other in Saturn's system. Outward from the planet, it spans nearly 1,000,000 kilometers, wide and faint and ethereal. But it is not a ring in the usual sense, not a sharp-edged band like the A or B rings. The E-ring is thick, cloud-like, almost more of a torus than a ribbon. It is composed mainly of microscopic particles, tiny grains of water ice that scatter sunlight, giving the ring a bluish, ghost-like hue. And it is astonishingly delicate. If you were somehow able to stand inside the densest part of the E-ring, you wouldn't feel like you were inside anything at all. The grains are spread so sparsely that the space would seem empty. You could wave your hand and pass through millions of particles and never touch one, yet taken together, over space vast enough to encompass multiple Earths, these grains reflect just enough sunlight for us to know they are there. Cassini flew through this ring multiple times, and on each pass, its instruments registered the fine touch of the particles, their shape, their size, even their composition. Most were nearly pure water ice, though some contained salts and organic molecules, hints of the subsurface sea from which they came. Every grain was a message in a bottle, flung outward from Enceladus's core, telling a quiet story about warmth, chemistry, and motion deep below the ice. And it's this connection, that makes the E-ring different. It isn't just a ring with a moon in it. It's a ring made by a moon, replenished in real time. The particles launched from Enceladus travel outward, some caught by Saturn's gravity, some nudged by electromagnetic forces, some pulled back by Enceladus itself. But enough remain in orbit to form this vast halo, ever-changing, always replenished. Without the moon's geysers, the E-ring would fade. But as long as Enceladus exhales, the ring endures. You could almost imagine Saturn itself breathing in time with that little moon. A vast planet orbited by a delicate veil, spun from the ocean of a body so much smaller. It's an inversion of scale. Mighty Saturn, adorned by the emissions of one of its least imposing children. And yet, in the vacuum of space, power is not always about size. Sometimes it's about persistence, about renewal. It's tempting to think of rings as still things, frozen arrangements of particles holding their place in silence. But the E-ring reminds us that space is not still, that even in the cold, even in the dark, processes unfold. Water boils, ice flies, grains drift, and scatter like snowflakes in a windless sky. The ring is not static. It pulses faintly, thickening and thinning as Enceladus's geysers rise and fall, as orbits shift, as particles are lost and replaced. There's a quiet grace to this system, a balance between destruction and creation that's rare in the solar system. Nothing is colliding here. Nothing is breaking apart. Instead, the E-ring is a portrait of resilience, a reminder that sometimes what's most extraordinary is not what explodes, but what endures. That from a single, consistent act, a moon erupting through its crust, can come something as vast and beautiful as a planetary ring. The E-ring, in all its fragility, is one of Saturn's most profound features. Not because it glows brightly, not because it contains massive structures or dense bands of ice, but because it shows a relationship, a connection between a planet and its moon, between geology and astronomy, between the deep interior of a frozen world and the light that catches on ice grains drifting 1,000,000 kilometers away. Every time Enceladus erupts, it tells us something about what lies beneath. And every particle that joins the E-ring carries that story outward, into sunlight, into visibility. The ring becomes a record, a halo made not of memory, but of movement, of change. And so it continues. Night after night, orbit after orbit, Enceladus breathes and Saturn glows. The E-ring shimmers on, a thin, drifting veil spun from a hidden sea, floating through space like a dream made of ice. They say the rings of Saturn are quiet, a slow-motion waltz of icy fragments circling a gas giant in serene loops, each particle following its path like a dancer in a celestial routine. But this stillness is an illusion. Beneath it is a constant reshaping, a choreography of push and pull, driven not just by gravity but by the invisible tension between order and chaos. And within this dynamic, Saturn's many moons take the role of sculptors, carving, guiding, maintaining the delicate structure of the rings through silent acts of influence. These aren't grand, distant moons like Titan, with its dense atmosphere and alien lakes. These are smaller, closer companions, shepherds, as we've come to call them. Shepherd moons don't lord over the rings from afar. They live inside them, at their edges, or within their gaps, embedded in the icy haze like seeds in a petal, moving not in dominance, but in intimacy. Each one plays a role, sometimes subtle, sometimes profound, in holding the rings together. Prometheus and Pandora flank the F-ring, a narrow, braided strand that would likely unravel without them. Prometheus orbits just inside the ring, tugging at particles with its gravity, pulling streamers of ice inward as it passes. Pandora, slightly farther out, counters with a gravitational nudge of its own. The result is a tensioned ribbon that flexes and twists, forming knots, wakes, and channels. The ring bends to their rhythm, reshaped with every orbit, like fabric teased by twin hands that never quite meet. It's easy to imagine these moons as caretakers, but they are not gentle. Their gravitational pulls may be small, but they act over thousands of kilometers, stirring turbulence into the rings, creating waves and ripples that spread like echoes across a pond. The ring particles, some no larger than grains of sand, others like boulders, respond to every pass, drawn toward the moon, then released, like dancers caught in a magnetic field. Some moons carve paths more directly. Pan and Daphnis, for instance, live inside the rings themselves, tucked within narrow gaps like beads on a thread. Pan inhabits the Inca Gap, while Daphnis sails the Keeler Gap. Both are ring-embedded moons, orbiting Saturn from within the ring's expanse. As they move, they clear paths, pushing aside particles, sweeping their orbital lanes clean like plows in a snowy field. And yet even their presence isn't so neat. Their gravitational reach extends beyond their gaps, tugging at nearby ring edges to create scalloped waves and fluted edges that ripple outward in both directions. These waves are not metaphorical. Cassini observed them directly, undulations rising and falling like sound frozen into shape. In some images, they resemble tiny hills on a flat plain, a reminder that nothing in the rings is truly still. Everything reacts, everything listens to the gravity around it. Some moons, like Mimas, don't need to be near a ring to influence it. Mimas, with its heavily cratered face and resemblance to a floating fossil, lies far outside the main rings, but its orbit resonates with particles in the Cassini division, the dark band that separates the A and B rings. This resonance creates a kind of orbital dissonance, a gravitational beat that clears particles out of that region, not by touch, but by rhythmic disruption. It's like shaking a table gently until the objects on it slowly drift to the sides. Over time, entire regions of the rings have been sculpted this way, emptied, tightened, refined, without ever being directly touched. This is the strange poetry of Saturn's rings, that something so vast, so seemingly formless, is shaped by such small forces. Not because the moons are massive, but because they are persistent. They orbit again and again, never pausing, never deviating, applying pressure in exactly the right places. Over years and centuries, their influence accumulates. What appears to be structure, gaps, edges, arcs, is the result of that invisible labor, and it's not a finished sculpture. The rings are in flux. The shepherd moons don't hold things in place so much as they maintain a kind of balance, delicate, constantly shifting, and utterly dependent on timing. If a moon's orbit changes even slightly, or if a new body enters the system, the balance ripples and reforms. The ring system we see now is not the one that existed a million years ago, and not the one that will exist a million years from now. It is a living map of the current state of influence, drawn in particles and traced by motion. There's something deeply comforting in that, to know that structure can come not from force, but from guidance. That patterns can emerge from repeated gestures, gentle corrections, and small, persistent pulls. The shepherd moons don't demand obedience. They coax it, quietly, in circles, and in their quiet guidance, there is elegance. The moons are not masters of the rings, but partners in their dance. Every orbit is a step, every gravitational tug, a cue, and in that dance, the rings find their form, not fixed, but flowing, like ice shaped by wind, or fabric carried by tide. Saturn, with all its grandeur, does not sculpt its own rings. It entrusts that task to these small, unseen sculptors, to moons that don't shine as brightly or capture headlines, but whose movements keep the whole system intact. The rings are their canvas. Their signature is not etched, but felt. In every curve, every division, every faint ripple trailing out across the dusk-lit loops of ice and rock. In the dark, where light barely touches, they shape the unseen. And the result is something we can see from Earth, a planet wrapped in poetry, a ring system both fragile and immense, guided by the gravity of companions who never stop dancing. From a distance, Saturn's rings feel timeless, ancient halos suspended in stillness, as if they've circled the planet since the dawn of the solar system, guardians of a legacy etched in ice. And for many years, that was the prevailing belief, that the rings were as old as Saturn itself, a permanent adornment spun from the same celestial cloth. But as our instruments grew sharper and our questions more curious, a new possibility began to whisper through the data. The rings may be young, not newborn, not freshly spun, but perhaps far more recent than we once imagined. In a solar system over 4.5 billion years old, the difference between ancient and young can be startling. The rings may not be timeless relics. They may be visitors, temporary, transient. Scientists have traced their suspicions through an unexpected clue: dust. Micrometeoroids, tiny grains of rock, metal, and debris, drift constantly through space, a kind of slow cosmic rain falling across every surface in the solar system. They are quiet and small, but relentless. Over time, they accumulate, layering themselves over moons, planets, and anything else that doesn't move quickly enough to shake them free. And if the rings had truly been around for billions of years, as old as Saturn's own formation, they should be dirty by now, coated in the dark soot of uncounted impacts, dimmed by the weight of time. But they aren't. They shine. The rings remain astonishingly bright, especially the A and B rings, with their vivid reflectivity and almost glassy gleam. Their ice is clean, almost too clean. Cassini measured the composition of the particles during its long mission around Saturn, and what it found suggested something surprising. These rings are composed almost entirely of water ice, with very little contamination. If they had existed for billions of years, they would have collected far more dust. They would be darker, duller, less pure. So something doesn't quite add up. To stay this clean for so long, the rings would need either a built-in cleaning mechanism, something sweeping them constantly free of debris, or they'd need to be much younger than expected. And of the two explanations, the latter is gaining more ground. By modeling the rate at which micrometeoroid dust should accumulate on icy surfaces, researchers have estimated that the rings might be no more than 100 to 200 million years old. In cosmic terms, that's recent. If this is true, it means the rings formed during the time of Earth's dinosaurs. When massive creatures roamed our planet, Saturn may have been gathering its icy adornments, perhaps through the destruction of a passing moon or a captured object that wandered too close and was torn apart by Saturn's gravity. A catastrophic event, frozen into beauty, a shattering that made something soft, and it raises even more questions. If the rings are young, are they a rare event? A fleeting phase in a planet's life? Could we be witnessing Saturn during a particularly glamorous moment in its timeline, one that will fade again with time? Some models suggest that the rings are already eroding, slowly but surely, their material drifting down into Saturn's upper atmosphere in fine, invisible streams. It's been called ring rain, and though it falls gently, it is persistent. Over millions of years, it may strip the rings of their mass, one ice particle at a time. We may be lucky to live during their peak. There's something bittersweet about that. The idea that these magnificent structures, so iconic and vast, may only exist during a sliver of Saturn's life. That we, with our telescopes and probes and curious minds, arrived just in time to see them in their full brilliance. A snapshot in planetary fashion, a phase, not a feature. It also reframes how we think about Saturn itself. What other versions of this planet have existed across deep time? How did it appear before the rings formed? If indeed they are young, was it more muted, more austere, the gas giant cloaked only in clouds? And what about the future, when the rings fade and fall away? Will Saturn become plain, undressed, no longer the jewel of the solar system, but something quieter, simpler, unadorned? There is no certainty yet. Some scientists still argue that the rings might be older and that we are misunderstanding the dynamics at play, that perhaps collisions and fragmentation renew the rings over time, or that Saturn's own magnetic field plays a role in clearing away grime. But the evidence keeps pointing to youth, to suddenness, to a recent arrival, and that makes them feel different. Not just ancient leftovers orbiting in predictable loops, but something alive in time, something temporary, like blossoms in spring, like a comet with a long glowing tail that won't always be visible. The rings, in this light, are not fossils. They are fireworks, brief, brilliant, and fragile. Perhaps that's why they fascinate us so deeply. We are drawn not only to beauty, but to beauty that might vanish. We are compelled by what is rare, what must be witnessed now, before it fades. And if the rings of Saturn are indeed young and fated to disappear, then every photograph, every observation, every hour Cassini spent drifting through their light becomes more precious. A record of something momentary, caught in its fullness, before it slips away. So the next time you look at Saturn, whether through a telescope or a high-resolution image, remember, you are not just seeing a planet. You may be seeing a moment, a chapter, a singular event in a long planetary story, one that will not be repeated, and one that we just happen to catch in time. Saturn, wrapped in rings that may not last, glowing like an echo of an explosion preserved in orbit. Here, now, and perhaps not forever. It's a strange thing, isn't it? To look at something so luminous, so delicate, and wonder whether it's a fleeting miracle or an ancient companion. Saturn's rings inspire that kind of question. They blur the line between what feels eternal and what might just be visiting. We've already floated through the theory that the rings are young, forged in some cosmic accident not long ago in planetary terms. But there's another idea, older and quieter, that maybe the rings are not visitors at all. Maybe they've always been here, or nearly so. To believe that is to entertain the notion that Saturn has worn these rings for billions of years. That as the solar system settled and formed, and chaos gave way to clockwork, Saturn gathered or retained this halo of ice. Not as a sudden event, but as a lingering feature, shaped over time. Not a temporary display, but a signature. There's something romantic in that too, that these graceful loops have witnessed the formation of moons, the cooling of planets, the steady spin of time itself. That they've survived countless impacts, solar flares, gravitational pulls, and nudges from all sides, yet remain intact, weathered, perhaps, but enduring. The idea of ancient rings doesn't come from wishful thinking. It's grounded in mathematics, in the gravitational choreography of Saturn's many moons and the rings themselves. Orbital dynamics, after all, is a language, a slow and precise conversation between mass and motion. And when scientists look at the current state of the ring system, some see the signs of age etched into its structure. They look at how the rings interact with moons like Mimas and Enceladus, how resonances shape gaps and edges, and how the orbits seem to have settled into patterns that would take far longer than a few 100 million years to establish. Like grooves worn into wood by years of passing hands, these interactions suggest a history far deeper than the pristine shine of the ice might reveal. Some models show that for certain orbital patterns to emerge, particularly in the dense B ring, time is essential. Not a few centuries, not even a few 100 million years, but billions. The kind of scale that mirrors the age of Saturn itself. And then there's the question of stability. The rings are remarkably orderly, despite their constant motion. particles orbit at different speeds depending on their distance from the planet, and yet large-scale collisions are rare. For such a massive system, its cohesion is uncanny. To achieve that level of harmony among countless particles, each the size of a snowflake or a bus, might require eons of natural sorting, where collisions resolve into balance and chaos quiets into symmetry. Of course, the cleanliness of the rings remains a challenge to this view. If they've truly been here for billions of years, then why are they still so reflective? Why hasn't the cosmic dust dimmed their shine? Some scientists suggest that the rings might have ways of renewing themselves, ongoing collisions between moonlets breaking apart, fresh ice being exposed, and fragments being recycled. It's a cycle of slow erosion and rebirth, like a river that never runs dry because snowmelt feeds it from upstream. In this model, the rings are not static, but dynamic, constantly losing mass, yes, but also gaining new material through the slow grinding of orbiting debris, or even from cryovolcanic moons like Enceladus, which spew ice into Saturn's gravitational well. The rings could be ancient, and yet always changing, always replenishing. This idea that something can be both old and alive is hard to measure but easy to feel, and it introduces a quiet debate, not one fought with outrage or certainty, but with gentle disagreement and shared wonder. Some astronomers look at the rings and see youth, others see age. Both camps bring compelling data, and both might be right in ways we don't yet understand. Perhaps the answer isn't either or. Perhaps the rings are remnants of something ancient, reshaped into their current form by more recent events. A kind of inheritance passed forward, renewed and rearranged. We do this with stories, don't we? We inherit them. We tell them again. We polish them. We let time smooth their edges. And even though the words may change, the essence survives. Maybe Saturn's rings are a story like that. A narrative written in ice, orbiting for ages, sometimes chipped, sometimes brightened, always moving. Not new, not entirely old, but both. A reflection of everything they've passed through, and everything still to come. It's worth remembering that space doesn't rush. Unlike us, it isn't pressed for answers. The solar system doesn't mind ambiguity. It turns, and waits, and lets things unfold. The rings don't explain themselves. They simply shine, sometimes brighter, sometimes dimmer, and invite us to ask. And we will keep asking. With each new mission, each refined model, we inch closer to a clearer view. But for now, the age of the rings remains a kind of quiet mystery, one that rests at the edge of brightness and shadow, between what is seen and what is still only suspected. Perhaps that's where their beauty truly lives, not in being understood, but in being wondered about. Saturn continues to spin, wrapped in its icy veil, and whether those rings have danced for billions of years or only just begun, they are here now, carving arcs across the dark, speaking in gravity, and glinting in sunlight. They are as close to timeless as anything we've yet seen. And maybe, just maybe, that's enough. Far out in the cold reaches of the solar system, Saturn turns, slow and unbothered, beneath its shimmering halo of rings. For now, they gleam like polished crystal, arching in perfect symmetry around the gas giant's middle, their icy brightness cutting through the dark like frost on a frozen pond. But not everything that looks eternal, truly island. Some things endure because we see them at their brightest moment, not because they are immune to time, but because we've arrived during the height of their unfolding. And so it is with Saturn's rings. They may not be here forever. In fact, they may already be leaving. It's a strange idea, isn't it? That something so vast, so visually dominant, could slowly fade away. That the very thing we use to recognize Saturn, to mark it out from the other planets, to decorate our textbooks and telescopes, might be temporary, but space has a quiet way of shifting even the grandest things towards stillness. And the rings, it seems, are no exception. The process is called ring rain. Cassini, the spacecraft that orbited Saturn for over a decade, made the discovery toward the end of its mission. As it dipped between the planet and its inner rings, it detected streams of charged particles, bits of ice and dust, falling from the rings down into Saturn's upper atmosphere. Not a torrent, not a cascade, but a steady, gentle loss, like sand slipping from an hourglass, invisible to the naked eye, but constant. Tiny particles, pulled by gravity, nudged by Saturn's magnetic field, drawn downward. And once they fall, they are gone. The scale of this descent is difficult to comprehend. Estimates suggest that up to 10 kilograms of ring material may be falling into Saturn every second. That's like a dozen elephants per moment, melting into vapor as they plunge through the atmosphere, disappearing without a trace. Over time, it adds up, and at that pace, the rings could be gone in just 100 million years. A long time to us, but a blink in planetary terms. The idea unsettles, gently. The rings feel like Saturn's identity, as if they belong to it in a way that nothing else could. It's hard to imagine the planet without them. To picture that golden disk, smooth and massive, but bare. No icy filaments tracing its waist. No shadows cast across its clouds. No jeweled crown. And yet, that may be Saturn's fate. The rings are already evolving. They grow thinner in places. New gaps form. Particles collide, break, reform, spiral inward. There is no violence in it. Just the quiet arithmetic of decay. A system slowly giving away its mass, one ice flake at a time. The outer rings stretch into whispers. The inner ones buckle and erode. And Saturn watches, unchanging, while its adornments dissolve. It's worth remembering that even beauty has weight. The rings are bright, yes, but they are also heavy. They demand energy to maintain their orbit. They feel the pull of Saturn's gravity and the subtle pressure of sunlight. Over time, these forces conspire to wear them down, to drag them closer, to fold them into the very planet they once encircled. There's a kind of poetic irony in it, that the rings, for all their elegance, might be nothing more than a brief phase in Saturn's life, a temporary embellishment, a showpiece, born from the wreckage of a shattered moon or captured comet, and now dissolving into the planet that held them. And that means we, as observers, are lucky. We live during the age of the rings, an age when Saturn wears its icy veil, when telescopes on Earth can catch the glint of sunlight bouncing off frozen arcs, when spacecraft can slip between those arcs and record their intricate structure. 100 million years from now, long after we are gone, long after the Earth has changed shape again, the rings may be only a memory, marked in craters on Saturn's surface or tiny traces in its magnetic field. But now, in this moment, they are here. They shimmer, they spin, they whisper their ancient secrets as they fall. This doesn't make them less beautiful. In some ways, it makes them more so. There is something profound in impermanence, in the awareness that what we're seeing is part of a larger story, one that includes not just presence, but passing. The rings are like a candle halfway burned, still glowing, still illuminating the darkness, but drifting toward an end we may not witness. And perhaps that's what moves us most. Not just that Saturn has rings, but that it has them now, that we, alive in this era of brief awareness, get to see them while they last, to capture their shine in our images and fold their wonder into our dreams, to imagine what once was and what someday may no longer be. It makes every glimpse more valuable, every photograph more precious, every observation a kind of preservation, like pressing a flower between the pages of a book, knowing it won't last in the field. But here, in this pressed space, it stays. So, as Saturn turns, and the ice drifts, and the rain falls, we listen. We listen to the long goodbye of the rings, not in sadness, but in awe, in gratitude, because for now, they are still here, and that is enough. Cassini did something no human ever could. It slipped between the veil and the planet, threading the narrow space between Saturn and its rings with a quiet grace. No fire, no roar, just a lonely spacecraft, decades old, carving a path through the most iconic halo in our solar system. And for a brief moment in 2017, it became a kind of celestial diver, plunging into the dark gap to see what no eye had ever seen before, a final act of intimacy between machine and mystery. Cassini's journey had already been long by then. It launched in 1997, coasted through the silence for nearly 7 years, then arrived at Saturn like a pilgrim reaching a long-anticipated shrine. It orbited the planet for 13 years, and during that time, it didn't just observe, it danced. Around the poles, across the moons, through shadows and storms. But it was the grand finale, as NASA called it, that elevated Cassini's voyage from mission to myth. 22 dives, each one threading the eye of a gravitational needle, arcing between the innermost rings and the tops of Saturn's cloud decks. A space so narrow and uncertain, no spacecraft had ever dared enter it. Scientists weren't even sure Cassini would survive the first pass, but it did. Again and again, each dive a passage into the unknown, collecting data, snapping images, tasting the particles in the air. Cassini didn't just observe the rings. It moved through them. Imagine it, a silent traveler sailing through a sea of frozen time. Icy particles speeding past, some no bigger than sand, others like boulders adrift in a slow-motion storm. It's not a collision course. It's a glide, a threading, like flying through a snowstorm frozen in midair. Each ring a swarm of fragments, orbiting with choreographed precision, yet constantly shifting, changing. Cassini moved through that motion like a ghost, never touching, only witnessing. And what it saw, the rings, from the inside, were not smooth. They were braided, knotted, tangled by gravity, and disturbed by moons. It found propeller-like structures caused by moonlets too small to be seen, stirring the ice like oars through a pond. It measured the density of particles, the composition of the ice, the echoes of collisions. It tasted the ring rain falling into Saturn's upper atmosphere. It saw textures, patterns, and shapes that had only existed as speculation before. What had once been an elegant blur resolved into structure, intricate, dynamic, alive. Cassini revealed that the rings were more than decoration. They were a system in their own right. A system of tension and balance, where every grain of ice tells a story about the moon it once belonged to, or the collision that shaped it, or the sunlight that wore it down. It showed us that the rings are not passive. They evolve. They are shaped from the inside and the outside. Saturn's gravity pulls them inward. Its moons push them outward. Sunlight alters their surfaces. Time thins their layers. And in that tension, they form spirals and waves, like ripples on a pond touched by invisible hands. Cassini gave us images too, photographs that now belong to the future. A view from between the rings, looking outward at Saturn's pale golden curve. Shots where the light catches 1,000 arcs of ice, gleaming like a chandelier spun in space. And in those final orbits, it turned its gaze inward, toward the planet, toward the place it would fall. The last dive wasn't into the rings, but through them. One last passage before Cassini surrendered to Saturn's gravity, plunging into the atmosphere in a controlled descent. Not because it failed, not because it was broken, but because that was the plan, to end it cleanly, to protect Saturn's moons from accidental contamination, to let it go in the same spirit that sent it, boldly, carefully, with reverence. As Cassini descended, it sent back data. Even in its final moments, it was learning, measuring the atmosphere, the magnetic field, the pressure, transmitting as long as its antenna could aim toward Earth, until the signal ended, suddenly and softly, like a breath drawn in and never released. A ship sailing through Saturn's sky, now gone, but not forgotten. Cassini left behind more than numbers and photos. It left behind understanding. It gave Saturn dimension and depth, and it gave the rings their detail. Before, they were symbols, beautiful, mysterious. Now they are histories written in orbit, glinting with ancient ice and quiet momentum. It's strange to think of a machine as brave, but Cassini earned the word. It dared to go where nothing else had. It flew not just toward the planet, but through its adornments, into its shadow, and finally, into its grasp. It met the unknown with grace, and in doing so, it gave us a clearer picture of this icy, swirling world. Now, when we look at Saturn through a telescope or in a photograph, we don't just see rings. We see stories, we see structure, complexity, movement. We see the place where Cassini flew, the path it traced, the dance it finished. And somewhere in that dance, between the bright arcs of the A ring, the ripples of the B, the wisps of the C, we remember that even the most distant places can become familiar. All it takes is the courage to go there, to move through the ice, not around it, to see for yourself what's on the other side. Cassini showed us, and for that, Saturn will never look the same. The silence of space is never quite what it seems. It's often painted as a vacuum of sound, a vast hush where nothing moves, nothing vibrates, and nothing dares break the stillness. But Saturn's rings tell a different story, one written not in volume, but in vibration, in charge, in shimmer and signal. The rings, those delicate arcs of frozen brilliance, hum, not with music as we know it, but with energy, with plasma, with the restless stir of electromagnetic life. It starts with motion, not the motion you can see, like the graceful orbit of ice particles or the dance of shepherd moons tugging at the edges. This motion is deeper, invisible, but no less real. The tiny particles that make up the rings, some no larger than grains of salt, others as wide as trucks, collide, scrape, charge, and release. They interact not only with each other but with Saturn's immense magnetic field, and that field, massive and rotating, reaches out and brushes the rings like a hand across strings. What follows is a kind of whisper, though not one that travels through air. It's a whisper of plasma, electrically charged gas, flowing between the rings and the planet. A current, subtle and steady, threading through the system like lightning slowed to a crawl. As particles in the rings become charged by sunlight or cosmic rays, they respond to the magnetic field, moving in loops and spirals, creating currents, waves, and even radio signals that race outward through space. Cassini, ever watchful, recorded these sounds. It carried instruments designed to sense what no human ear could. In its orbit, Cassini picked up pulses and bursts, static and chirps. Radio emissions created by the interaction between Saturn's magnetic field and the particles trapped within it. These emissions weren't just data. When translated into audio frequencies, they became something eerily musical, like the echo of a storm beneath the waves or the song of a giant machine dreaming in its sleep. The rings hum. They don't simply reflect sunlight. They participate in a dance of energy that stretches from their icy grains to Saturn's poles, where auroras bloom in ultraviolet spirals. Saturn, like Earth, has auroras, vast glowing curtains shaped by magnetic fields and the charged particles they guide. On Saturn, these auroras are fed not only by the solar wind, but by the rings themselves, and by moons like Enceladus, which spews out geysers of icy material into the field. This interaction between particles, fields, and flows forms a system not of silence, but of layered rhythm. Saturn becomes not just a planet, but an instrument, and the rings are not decorations. They are part of the melody. It's not a melody we can hum. It doesn't follow a scale or sit neatly on a staff. It's chaotic, mathematical, shaped by forces so vast and ancient they forget the measure of time. But it's there, a chorus of electrons spiraling through magnetic lines, a harmony between mass and field, each particle a note, each collision a beat. Together, they create the unseen song of Saturn. Scientists call it plasma wave science or magnetospheric dynamics, but names are only handles. The reality is stranger and more beautiful than the words that try to hold it. Imagine a ring system, not silent, not still, but alive with vibration, with invisible symphonies echoing across millions of miles, reaching from the edge of the rings down to Saturn's cloud tops, where they melt into the auroral glow and disappear. And the rings, those quiet arcs we see as frozen, become conductors. They channel, they reflect, they contribute, like tuning forks set into orbit, resonating with the field that holds them. Even more curiously, there's evidence that the rings themselves may be shaped by these electromagnetic forces, not just physically, but spatially. Certain gaps, ripples, and even brightness variations may result not from collisions or gravity alone, but from these deeper, invisible interactions. Plasma waves strong enough to sculpt the ice itself, carving subtle patterns into the orbiting dust, like a stylus tracing a groove on vinyl. Saturn spins quickly, about 10.5 hours per rotation, and this spin generates a powerful magnetic field. But unlike Earth's magnetic field, Saturn's is almost perfectly aligned with its axis of rotation. That means it doesn't wobble or shift in the way scientists expected. Cassini's data forced researchers to reconsider even basic questions, like how long a Saturnian day truly is, or how deep the field reaches into the planet. The answers remain elusive, but the rings, with their plasma hum, are helping to tell the story. They act as detectors. They echo and respond to what Saturn's field does. By studying those echoes, scientists learn not just about the rings, but about the planet they encircle. It's as if the rings are listening constantly, and what they hear becomes part of their shape, their motion, their glow. All of this happens in silence that isn't silent, in a vacuum that sings. We don't hear it from Earth. Our ears are too slow. The sound is too high, too low, too fast, too strange. But the instruments catch it. They translate it. They bring it back. And when we listen to those eerie recordings, those chirps and whistles that seem like they belong to birds from another dimension, we're hearing not just Saturn, but the music of a planetary system in full expression. It reminds us that space is never still. Even the coldest reaches are alive with energy, with hums, with tides of force we can barely name. Saturn's rings are not the quiet, frozen halos we once thought. They are loops of motion, threads of energy, singing softly to the magnetic rhythm of the giant that holds them. And in the emptiness between the particles, in the charged paths they trace, a symphony unfolds, forever unheard by human ears, but always playing, always there. A lullaby written in plasma, drifting through the dark. There's a quiet tragedy to Saturn's rings, once you understand where they may have come from. At first glance, they seem impossibly delicate, loops of light, peaceful and serene, orbiting the planet in eternal grace. But behind their beauty might be a moment of chaos, of shattering, of celestial violence that left behind not a corpse, but a crown. The leading theory suggests the rings were born not by slow accumulation, but by sudden destruction. Not in the beginning of the solar system, but long after. A moon, once whole, once moving faithfully through its orbit, torn apart by forces stronger than it could survive. Perhaps it wandered too close to Saturn, where tidal forces grew ruthless. Or perhaps it was already wounded, cracked by ancient impacts, its core fractured and fragile, and Saturn's gravity did the rest. This moon, this silent companion, would have once had a name, or it should have. We don't know it now. No catalog holds it. No telescope captured it before it was lost. But something had to be there. A body with enough mass to account for the billions of tons of material that now orbit Saturn in a broken spiral of ice and dust. The mechanics are brutal. If a moon comes within the Roche limit, a distance where a planet's tidal forces exceed the satellite's own gravity, it begins to pull apart. The outer layers might peel first, then the crust, the rock, the frozen oceans if it had them. Eventually the core gives way. No explosion, just a stretching, a grinding, a gradual unraveling, until what was once a sphere becomes a stream, a spray, a belt of debris slowly spreading into the smooth arcs we now see as rings. It's easy to forget, when looking at the rings from afar, just how much energy is involved. Each particle in the ring system was once part of something whole, a mountain, a valley, maybe even a surface touched by sunlight. Now those pieces race around Saturn at incredible speeds, up to 70 kilometers per hour. Yet to our distant eyes, they look serene, like frost on a window, like a lace collar around a golden giant. But that grace is the result of wreckage, of disassembly so complete that it achieved balance. The violence is hidden now, long past, buried in silence. Cassini's data supports this idea. It measured the composition of the ring particles and found them to be overwhelmingly made of water ice, over 90% in fact. Almost too pure. That's a clue. If the rings were formed from leftover solar system material, from the original disk of dust and gas that birthed the planets, we'd expect more dirt, more rock, more metallic debris. But what we see instead is ice. Clean, bright, reflective. The kind of ice you'd expect from the outer layers of a moon. A moon like Enceladus or Tethys, perhaps. Moons with icy crusts and mysterious pasts, still orbiting nearby, perhaps siblings of the one that didn't survive. And so the theory unfolds. That Saturn's rings are not an ancient feature, but a monument to a recent loss. Recent in planetary terms still means tens of millions of years, but not billions. Not from the dawn of the solar system, but from its adolescence. Perhaps at a time when dinosaurs walked the Earth. Somewhere, far above, a moon was dying, and Earth never knew. That moment of destruction would have echoed across space as a kind of invisible thunder, not in sound, but in motion. An entire world broken, strewn across the sky, settling into new paths. And over time, those chaotic orbits smoothed. Gravity softened their jagged trajectories. The debris thinned into rings, spread by collisions and resonances, shaped by Saturn's moons into ribbons and gaps. A scar transformed into an ornament. This idea, the ring system, as remnants, is not a mournful one, though it carries a kind of melancholy. It reminds us that beauty often has roots in sorrow, that even destruction, on the scale of moons and planets, can give rise to elegance and order. The rings became a memory etched in motion, the slow, glinting echo of something that once was. And perhaps that's what we're seeing when we gaze at Saturn through a telescope or in spacecraft imagery. Not just ice and dust, but memory, a history, written in orbit. The physics supports it, but the poetry completes it. Because to look at the rings and understand they may have formed from a lost moon is to see the planet not as a cold, distant world, but as a stage for drama we can barely comprehend. Saturn didn't want the moon to die. It only obeyed gravity, just as the moon did, up until the very end. That's the terrible balance of the cosmos. Nothing personal, just force, just mass and distance and inevitability. Still, something lingers in the patterns of the rings, in the brightness of the ice, in the silence between particles, something like a ghost of what came before. And so, the next time you see Saturn's rings, remember that they may not be ancient after all. They may be young, they may be temporary, they may be the result of a celestial accident that happened after the solar system settled, after life began on Earth. A final, desperate unmaking that left behind not rubble, but rhythm. A shattered moon, frozen into a halo. The planet keeps spinning, the rings keep shining, and somewhere within them, a story of loss is still unfolding, one orbit at a time. Jupiter has them, so does Uranus. Neptune, too. Rings, soft and subtle, looping faintly around distant worlds. But if you didn't already know, you'd never guess it. Their rings are quiet whispers in the cosmic dark, threads of dust and shadow that barely catch the sunlight. Nothing like Saturn. Saturn doesn't whisper. It glows. It dazzles. It wears its rings like regalia, like a beacon drawn in ice, meant to be seen from across the solar system. The other ringed planets keep their halos close, as though reluctant to be noticed. Jupiter's rings are made mostly of dust, particles so fine they scatter light like smoke. They hug the giant planet tightly, almost shy. The Galileo spacecraft passed through them, and even then, they were hard to see. Faint arcs lit only when the sun hits them just right. Not grand, not gleaming, just there, like ash orbiting a fire that no longer burns. Uranus, the tilted one, carries a darker set of rings, 13 narrow bands of rock and debris, discovered not through images but by their absence. In 1977, scientists observed a star blinking as it passed behind the planet. The blink wasn't random, it was rhythmic. That rhythm revealed the rings. They aren't bright like Saturn's. They're soot dark, likely made of radiation-baked particles, lacking the icy sheen that turns Saturn into a chandelier. But they exist, circling like silent sentinels around a world that spins on its side, a mystery all its own. Then there's Neptune, the farthest giant, with rings that seem to flicker in and out of view. Some of its arcs are complete, others are fragmented, as though unfinished, like sentences whispered in a storm. Voyager 2 saw them in 1989, when it flew by on its one and only visit. And even then, they were elusive, hard to capture. Dust and ice, once again, clinging to a cold world adrift in the blue distance. So yes, Saturn isn't alone in wearing rings, but it is alone in how loudly those rings sing. Saturn's rings are wide, incredibly wide. If you could unspool them and lay them flat, edge to edge, they'd stretch farther than the distance from Earth to the Moon. And yet, they're thin. So thin, they almost vanish when seen from the side. Their brightness is what makes them special, a gleam that catches sunlight and throws it back with grace. That gleam comes from ice, not dirt, not dust, but crystalline water ice, shattered and scattered, catching light like glitter on the wind. That's why we see them. That's why we marvel. Not because Saturn is the only ringed planet, but because it's the only one that chose to wear its rings like a crown instead of a cloak. And perhaps that's what makes this comparison so oddly beautiful. It reminds us that the universe isn't short on mystery, that even among similarities, uniqueness finds a way. All four gas giants have rings, yes, but only one of them announces it with drama. The rest stay quiet, reserved, as if protecting a secret. Saturn, on the other hand, shares its secret freely. Imagine looking up from a moon like Enceladus or Titan and seeing that arc in the sky, vast, gleaming, layered. Not a line, but a structure. Not a band, but a world of motion. Millions of particles, all orbiting in silent coordination, forming a system that glows like a frozen ripple around a gas giant so immense it could swallow Earth hundreds of times over. There's something humbling about that, and there's something comforting in it too, that we live in a solar system filled with echoes and variations, that rings can appear in many forms, that beauty doesn't have to be loud, but when it is, like Saturn's, it becomes unforgettable. The faint rings of Jupiter, Uranus, and Neptune are there. They are real, physical, measurable. They just aren't meant to be the center of attention. They're the background music in a room where Saturn plays the symphony. They orbit, they endure, they persist, but they don't light up the stage. It's tempting to imagine what our night sky would look like if Saturn were as close as the moon. Its rings would stretch wide enough to dominate the horizon, a constant arc across the sky. A reminder of motion, of scale, of elegance born from chaos. But perhaps it's better that Saturn remains where it island, distant, mysterious, and just close enough for us to wonder. Because in that wondering, we get to explore not just what Saturn is, but what makes it special. We compare, we contrast, and through that lens, we learn something vital, that even in a universe of similarities, every world carries its own fingerprint. Saturn's rings are a masterpiece, but they're not the only artwork in the gallery. They're just the one illuminated by a spotlight. The others, quieter, darker, softer, are no less real. They remind us to look carefully, to listen closely, to respect the unseen. Because even shadows have stories, and even the faintest rings still sing, if you learn how to hear them. On a cool, clear night, when the air settles and the light pollution retreats just a little, you might find yourself drawn to the sky, not just to glance, but to really look. Perhaps you're standing on a quiet balcony, or in the hush of a backyard, or wrapped in a blanket in the open stillness of a field, peering through a modest telescope or a pair of well-balanced binoculars. If the timing is right and the sky is kind, you'll catch it. A small but undeniable shape, not just a dot of starlight like the others, but something different, brighter, elongated, haloed. Saturn, even with a beginner's telescope, no more powerful than what a curious child might unwrap on a birthday, Saturn reveals itself. Not in ultra-sharp detail, not like the glossy pages of a science magazine or the crystal-captured images sent down by Cassini, but something real and yours. You'll see the planet suspended in velvet black, and around it, faint but firm, the rings, a presence so improbable it feels like magic. But there they are, perfectly curved, encircling that distant world, like a whisper frozen in light. They don't look huge, at least not through a small scope. But they don't need to. Their impact is emotional, not just visual. To see them for yourself is to be reminded, in real time, that you are staring across hundreds of millions of miles, that a tiny glass lens, here on Earth, can collect photons that have bounced off icy particles in the outer solar system and carry them, delicately, to your eye. You're not just observing, you're receiving. Even binoculars, if the magnification is strong enough and your hands are steady, can hint at something more than a dot. You won't resolve the rings in perfect clarity, but you'll notice the elongation, the shape that doesn't quite match any star or planet you've seen before. And maybe that will be enough to pull you in, to make you wonder what else you might see if you just looked a little longer. It's worth remembering that some of the earliest telescopes were not that different from what you might hold in your hands today. When Galileo first turned his primitive scope to the heavens in 1610, he saw Saturn and was perplexed. He described the planet as having ears, not yet understanding that he was seeing rings from an angle his instruments couldn't fully resolve. He thought it might be three bodies clustered together, or some odd bulge around the central sphere. The truth was beyond his reach, and yet he knew enough to sense that something extraordinary was there. Later, with better lenses and clearer skies, astronomers like Christian Huygens and Giovanni Cassini began to piece it together. Huygens proposed the idea of a ring in 1655, and not long after, Cassini spotted the gap that now bears his name. The more they looked, the more Saturn revealed. And each generation that followed them, with stronger optics and deeper questions, saw more. But even now, with space probes and supercomputers, that first glimpse through a telescope still holds its magic. Because this isn't about resolution or data. It's about standing here, in your quiet place, and knowing that you are watching something ancient, something that has been turning and glowing and scattering sunlight for eons before humans ever thought to look up. Saturn has worn those rings longer than there have been eyes on Earth to see them. And yet, tonight, with your small telescope balanced on its tripod and your breath fogging the eyepiece, you are part of that story. There's something tender in that connection. You, here on Earth, spinning slowly through your own night, reaching out with optics and wonder toward a world that feels almost mythical. The fact that you can see Saturn's rings at all from this distance is a reminder of how generous the universe can be with its beauty. It doesn't hide it all. It gives us glimpses. And maybe, as you're standing there, you think about all the others looking up at the same moment. Strangers with scopes on balconies, amateur astronomers on rooftops, children holding binoculars with both hands. A quiet chorus of eyes pointed outward, all catching that same glint of light, that same tilt of rings, across cities and continents. In the end, it's not the size of your telescope or the sharpness of the image that stays with you. It's the realization that this majestic thing is real. That Saturn is out there, glowing, turning, radiating its icy halo into the cosmos, waiting patiently for you to find it. And once you do, you don't forget. Because when you see Saturn's rings with your own eyes, however faint, however small, you carry them with you, in memory, in wonder, in the quiet knowledge that even from this far away, you were able to reach them. Out there, in the vastness of the solar system, Saturn still spins, slowly, patiently, like a dancer caught in an eternal pirouette, wrapped in 1,000 veils of ice and dust. The rings shimmer not because they try to, but because sunlight simply finds them. They do not announce themselves. They do not chase attention. They just are. And somehow, even from this far away, you can feel them. But here's the quiet truth, the one that hums beneath all of this. Those rings, those fragments of frozen water and fractured stone, aren't as distant from you as they seem. Because the story they tell, the story of collision and light, of silence and spin, is your story too. The water that flows through your veins, the calcium folded into your bones, the carbon etched into every cell of your body, all of it came from stars. Not metaphorically, literally. The heavy elements that make life possible were forged in ancient stellar furnaces scattered across space when those stars died and breathed their last. Supernovae shook the sky, and from that chaos came chemistry. And from that chemistry, eventually, inevitably, came you, which means, in a very real and measurable way, that the particles drifting in Saturn's rings, the glacial grains that catch sunlight and bend it toward Earth, are made of the same cosmic fabric as you. You are not watching something foreign or other. You are watching a sibling in orbit, a companion crafted from the same scattered stardust, shaped by the same universal laws. And just like the rings, you are held in motion, not static, not still. Even now, you are spinning on a planet that rotates beneath your feet, around a star that rises and sets, inside a galaxy that swirls like smoke. You are never truly still. You are part of this rhythm, this silent, invisible dance. There's comfort in that, in knowing that even in moments of solitude or stillness, even as you lie quietly now, wrapped in soft shadows and slowing thoughts, you are not apart from the cosmos. You are folded into it, bound to it. You belong to the same story that Saturn tells with every rotation, every icy orbit, every whisper of light flung across space. And so, as we drift back toward silence, let yourself imagine it, not from the distance of telescopes and textbooks, but from within. Picture the rings not just as something you observe, but something you remember, something you return to. Let your breath sink with their orbit. Let your thoughts settle like ice on the edge of gravity. Let your heart, in its quiet pulse, echo the rhythm of moons and dust. You are not far from wonder. You are made of it. You are made of water, just like the rings, of dust, just like the bands that ripple and blur between Saturn's moons, of carbon, the same element that traces lines through meteorites and makes comets shine when they greet the Sunday. Every part of you holds a record of the cosmos, like a diary written in atoms. And maybe, just maybe, that's why Saturn feels familiar. Not because you've seen it through a telescope or studied its arcs in a book, but because some ancient memory stirs when you look its way. A kind of resonance, a quiet recognition. In the cold geometry of those rings, there is poetry. In the chaos of ice colliding and reforming, there is order. In the darkness between the particles, there is light scattered and reflected and sent outward like a message. And in you, in the softness of your skin, in the weight of your breath, in the thoughts that slow as you ease toward sleep, there is something no less profound. So now, let go of the day. Let go of what came before and what waits beyond the next dawn. The stars will keep their places. The rings will keep turning. Saturn will hold its path. And you, part of all this, can rest in the knowledge that you are not separate from the night sky. You are not simply a visitor. You are a participant. You are a part of the orbit, the dust, the song of light across distance. And in this quiet moment, you are home.